Hi there. I am from Group 2G. And I would like to present the members of the group. My name is Omar Farouk.
Hi. My name is Nurul Jana.
Hello. My name is Kuekais Hyong.
Hello. My name is Nuabakis.
In this video, we will explain about 5 things, which are the type of reaction involved, the reactants used, and products of biodiesel. One relevant solid catalyst for this reaction. General procedure for the preparation of the catalyst. Suitable characterization techniques. To investigate the chemical, physical and morphological properties of the proposed catalyst. A suitable catalytic reactor for the production of biodiesel. And trends and challenges in production of biodiesel in Malaysia. What is a biodiesel?
Biodiesel is a form of diesel fuel derived from plants or animals, and consisting of long-chain fatty acid esters.
It is an alternative fuel similar to conventional or fossil diesel. It also can be produced from straight vegetable oil, animal oil or fats, tallow and waste cooking oil, by a process called transesterification.
We have identified the type of reaction involved, the reactants used, and its products. Catalytic transesterification is the type of reaction used in producing a high yield of biodiesel. Biodiesel production is done by transesterification of triglycerides from a catalytic standpoint. It occurred through transesterification of oil with methanol in the presence of a catalyst. As for the product, biodiesel is the major product, and glycerol as a byproduct.
We have chosen the best solid catalyst for the reaction. And we made a comparison from 4 different catalysts, which are potassium hydroxide/aluminium oxide, calcium oxide, Nafion NR50, and tungsten trioxide/zirconium dioxide. As we have known, potassium hydroxide/aluminium oxide has high selectivity, high activity, high reaction rate, and low cost. Meanwhile, calcium oxide and tungsten trioxide/zirconium dioxide have lower reaction rate. Nafion NR50 has higher cost compared to potassium hydroxide/aluminium oxide. This proves that potassium hydroxide, aluminium oxide, is the most suitable solid catalyst for the reaction.
There are 9 steps in general procedure to prepare the catalyst. First, impregnate aluminium oxide support with an aqueous solution of potassium hydroxide. Second, calcine aluminium oxide support in powder form in muffle furnace for 7 hours at 700 Celsius. Third, cool down to room temperature. Fourth, add potassium hydroxide solution slowly on granular aluminium oxide. Fifth, stir the content continuously for proper mixing. Sixth, add potassium hydroxide solution to support until all aluminium oxide granules are dipped. Seventh, stir the solution for half an hour. Eighth, dry prepared catalyst in an oven at 110 Celsius for 24 hours. Lastly, calcine the catalyst at 500 Celsius for 3 hours.
We discovered that there are 3 suitable techniques to identify the properties of the catalyst, which are X-ray diffraction. X-ray diffraction is performed using Siemens D500 diffractmeter with copper K-alpha irradiation, step size in 0.05 degrees steps in 3 seconds to identify the crystalline phase of the calcine catalyst composition. Then, scanning electron microscopy, as known as SEM. With the increase in the temperature, the surface morphology of the catalyst changed distinctly. For example, when the calcination temperature was 700 degrees Celsius, there was a good distribution of Co on the support surface, due to the particles congregated into a huge agglomeration. Next, Brunauer Emmett Teller, BET, Specific surface area and pore size were measured by the Brunauer-Emmett-Teller method at liquid nitrogen temperature -196 Celsius using a Micrometitics ASAP 2000 analyzer.
We also have chosen the most ideal catalytic reactor, which includes 2 fixed-bed reactor columns fed with vegetable oil and methanol, which, excessive methanol is removed after each reactor by partial evaporation. Then, esters and glycerol are separated in a settler. Glycerol outputs are gathered, and the residual methanol is removed by evaporation. The purification section of methyl ester coming from the second decanter consists of methanol vaporized under vacuum followed by a final purification in an adsorber for removing the soluble glycerol. The reasons we chose this type of reaction are: first, fixed bed reactor designed to overcome the inhomogeneous condition. Second, vegetable oil and methanol is mixed inside the reactor. Third, oil and methanol mixture were forced to flow through the space between catalyst. Fourth, mass transfer resistance is decreased by reducing the boundary layer, which improves the contact between reactants and catalyst.
The need to develop biodiesel fuel is growing day by day. The development of biodiesel began in 1981 until 1985, which Malaysian Palm Oil Board began first pilot palm oil plant project. In 2001, use of CPO and fuel oil blend for power generation initiated. 2006, National Biofuel Policy launched. 2007, Malaysian Biofuel Industry Act 2007 implemented for palm biodiesel. 2011, launch of B5 blend, which is 5% palm oil and 95 petrol diesel. 2014, launch of B7 blend 7% palm oil. 2018, launch of B10 blend 10% palm oil. 2020, scheduled launch of B20 blend, which is 20% of palm oil. Even the biodiesel production is developing, there are still challenges are faced. Firstly, relative pricing. The production of biodiesel from palm oil was no longer economically feasible, as its retail price had to approach the price of cheaper petroleum-derived diesel. Second, food and environment debate. The increase in palm oil for biodiesel could cause a shortage of palm oil, raising its price, and deforestation has continued at a much faster pace. Third, exportation barrier. There are countries still have complete freedom to impose certain restrictions and non-tariff trade barriers on imported goods. Fourth, government policy. It is difficult for the Malaysian government to further advance the biodiesel industry without cooperation from the private sector. Fifth, research and development. Malaysia has limited arable land and is constantly being attacked by environmentalists to cut the vast tracts of rainforest. Lastly, raw material. Over-reliance on palm oil for larger-scale biodiesel production will certainly drive up the price of crude palm oil, thus making production economically unviable.
And that's all from us. Thank you.